Today we are looking at 8.2/6.5 combining transformations. So we're going to put together all the different transformations that we learned in this unit. And in this first example, it's a really good way to compare what happens when we do transformations in different orders. So in part A and B, we're going to do the same two transformations, but in different orders. In A, we're going to graph H by first shifting horizontally 6 units. So go ahead and do that on your graph. And there it is if I just drag it over to the right 6 units. And then what I'm going to do is I'm going to compress it horizontally by a factor of a third. So I'm going to take all the x inputs. So this first point is a 2, -1. And I'm going to divide the x inputs by 3. So it becomes 2/3. -1. I'm going to do the same thing with this next point up here that I'm pointing an arrow at. That point is at 3, 2. If I compress that horizontally by a third, it's going to go to the point 1, 2. So I'm going to bring all those in. So 4, 0 becomes 4/3, 0. The next one I have is at 6, 2. So that'll become 2, 2, etc. And I'm going to go ahead and draw this final transformation here. So this should be my end result. I was trying to go over it a little better there. Let's see if I can go over that one more time to make sure it shows up really good. This is my end result when I go in that order. This is part A specifically. Now part B is going to have us do the exact same thing, but we're going to go in a different order and our end result will be a little different. So let's take a look at that one. In part B, we're going to first compress it horizontally by a third. So I'm going to right away compress that horizontally by a third. And you see this kind of M shape right here. I have it in green. And notice it goes through the point 0, 2. That point did not change. And then what I'm going to do now in the second step is I'm going to then shift it horizontally to the right by 6 units. So I'm going to drag all these points to the right 6 units now. And I went ahead and shifted those points over. I'm just connecting them here now. So this would be my end result over here to the right. It looks like basically the same shape as my original answer, but it's definitely going to be shifted over a bit farther. So that's different. So here's my first answer. That's part A. Here's my second answer. That's part B. One had a larger shift in the end compared to the other. Now, what we're going to do in part C is we're going to go ahead and compare the graphs. So we already did that. We said that just one ends up being shifted more to the right, but we also want to write the formulas. We haven't really done that yet. And we were supposed to do that in part A and B. So let me just label that this first one was the part A one and this second one was the part B one. Now let's go ahead and write the formulas for these in terms of, the original function. So when we write that formula for h of x, the first thing we did was we shifted it to the right 6. So we do g of x minus 6. Remember that opposite sign for the inside. The next thing we did after that was we did a horizontal compression by a third. So we're going to multiply a 3 in here. Notice I will not put another set of parentheses because inside stuff always works a little backwards from what you think. So I put the 3 right there. This would be the equation for your h of x function from part A. If I do the equation for the k of x function in part B, in this one I'm going to do the compression first, so g of 3x, and then in my next step I'll go ahead and shift it. Well, because I'm doing the shift next, I need to go g of 3 parentheses x minus 6. So again, the 6 is the more inside transformation, but because it's inside, that's actually the last thing that I do. Well, because one of these has a 3 factored out and one does not, it ends up with different type of shifts. We call one of these a phase shift and we call one of these a horizontal shift. And this will be very important for our trig functions that we graph. So let's talk about the difference of horizontal shifts, which is like what we see here when it's factored out in part B, versus phase shifts, which is what we see up here when it is not factored out in part A. So let's go through some notes here for this. So if I have a sinusoidal equation and it looks like y equals sine, or it could be cosine, doesn't matter, and I have a b that is factored out times an x minus h. Again, this could also be a cosine equation. So it could be cosine of b parentheses x minus h. When it is factored out like this, then we call this a horizontal shift. So that shows us a horizontal shift by h units. If I do not have it factored out, so if I instead have y equals sine, I'm not going to use b again, or I am going to use b, I'm sorry, I'm not going to use h again. I'm going to go ahead and call it bx minus phi. Phi is just a Greek letter, but it's often a variable we use for a phase shift. I know that's kind of weird. Don't worry too much about that. And again, this could be sine or cosine. So I could have sine or cosine. Notice here, what I really want you to pay attention to is that the b is not factored out. So I have a bx minus some phi, whatever variable that is. This phi is now what we call a phase shift. So it tells you a proportional amount to shift over, but it doesn't tell you like how far to count it over. So what the phase shift is it is a fraction of the full period that we get shifted over. Now, I personally am not as big of a fan as phase shift. So I will typically do everything with horizontal shift. So if mine is not factored out, I just factor it out and then I can use horizontal shift. If you like phase shift, then you are welcome to use it. And if you do not like phase shift, you can use horizontal shift every time for this course. Let's take a look at understanding this phase shift concept. In example 2, it says, by what fraction of a period is the graph of g of t shifted from the graph of f of t? Go ahead and answer that in the Edpuzzle. And when we look at this graph of f and we want to imagine how far forward this is shifted to become the dash graph, which is g, it appears it is shifted 1/4 of the period. That's how far to the right it is shifted, 1/4 of the period. I don't know what the period is, but it's shifted 1/4 of the way. There's 1 tick mark, 2, 3, 4. 4 is a full period, and it's shifted 1/4 of the way forward. So we call the phase shift then 1/4 of the period. So the phase shift is 1/4 of the period. This is a basic sine or cosine function. So in this case, when we say 1/4 of the period, we're saying 1/4 of 2 pi. And 1/4 of 2 pi becomes pi over 2. So that is the phase shift. The phase shift is a value pi over 2. Pi over 2 means shift 1/4 of the period. And that's important language because the period is going to change for different functions. And we'll come back to that. Example 3 wants you to rewrite the function shown in the other form, which just means factor out the 2, and then describe and order the transformations. Go ahead and choose the correct version on the Edpuzzle now. So what we want to focus on in example 3 is the order of transformations, because as we saw in the first example, the order as it changes really affects the graph. So when we factor out the 2, this function becomes f of 2 x minus 3, looking like this. So the first transformation, remember when we start on the inside, it's the opposite of what you think. So it looks like it's going to be the minus 3. The first transformation is actually going to be the times 2. The times 2 really will do a horizontal compression by 1/2. A horizontal compression by 1/2. The second transformation will then be the minus 3, which will, of course, shift over to the right 3. Now, the inside transformations are a different order than the outside. So let's do a final summary of ordering all transformations. We are going to take a function in terms of f and put in all these transformations. Notice that the b is factored out in this case like a horizontal shift. And I will do that all the time for my problems, although I'll try to show you guys how to use phase shift as well as we move forward. So the first thing you're always going to do is start with the inside stuff. And the very first guy that you deal with is the b. So we take this b here. And what we're going to do is we are going to do a horizontal stretch or compress, depending on what b is, by 1 over b. So if it's a times 2, you compress by 1/2. If it's a 1/3, then you're stretching by 3 or whatever. If b is negative, then you want to right away reflect it over the y-axis as well. The second thing we're going to do is we're going to deal with this minus h. This is the other inside transformation. So we do all the inside changes first. The minus h will either shift it left or right. So depends on if that is actually minus or if it, the h is negative, it'll change the sign. So the second transformation is always a horizontal shift by h units, either going left or right. So we start with our 2 inside changes. Then after that, we do our next 2 outside. So we start in and work our way out. Now the outside things are more intuitive. When I work my way out, I go in the order I want to. So I do that times a first. So the a happens there first. So I'm going to do a vertical stretch or compress, and I don't have to flip the a this time. I just do it right by the a. So if it's a times 3, then I'm stretching by 3. Again, if that a is negative, do the reflection right there in that step, reflect over the x-axis. And then the very last thing I'll do is this plus k, which is going to be a vertical shift by k units up or down, whichever, depending on the sign. So let's go ahead and take a look at example 4. Given this function, you're going to put it into that form and identify all transformations. Go ahead and choose the correct form on the Edpuzzle. The form that you wanted to choose, it has the negative 1/3 factored out. The way it's given to you, it's factored out. So we want to basically redistribute it. It's going to go in front of the f and apply to the plus 3. So we're going to have a negative 1/3 f. Factor out the 2 in here so we can get this looking like a horizontal shift. And then the negative 1/3 also applies to that plus 3, so it'll make that a minus 1 at the end there. You want to be really careful that you caught that. Now go ahead and identify all transformations in order. And starting inside and working our way out, we're going to horizontally compress it by 1/2 and then shift it right 4. We're going to vertically compress by 1/3 and reflect it over the x-axis. And then the very last thing will be to shift it down 1. So 4 transformations in total, kind of 5 if you think about the reflection as a separate transformation. So now let's look at how this affects our sine and cosine functions, because that's our real goal here. So the first thing we have is helpful hints for finding equations of sinusoidal functions. The first thing is if it starts on the midline, then you're going to go ahead and write a sine function, because our sine function, I'm going to just draw this on the left here, starts on the midline, right? That's a 1 period of sine. Our cosine function always starts at the top. That's our cosine function. So here's sine of x and here's cos of x. So if instead the starting point is on the max or minimum value, if it starts at the top or the bottom, that's when you would want to write a cosine function. Then you don't have to deal with shifting. Changing the sign of the a value is always going to reflect the graph over the midline. So if it starts at the bottom, for example, at a minimum value, you can make it a negative cosine, and then that'll, be equivalent there. So let's go ahead and try this. So we're going to attempt to write formulas for our 2 functions here. In this first function, I see it starts on the midline. So I'm going to do this with a sine function. So I'm going to go ahead and write a sine function. Pardon, I don't know what's happening here. That was weird. Sorry about that interruption. So I'm going to go ahead and write a sine function since it's starting on the middle. The amplitude, it goes up 1, down 1. So that did not change. And I don't need a horizontal shift if it's starting on the middle. So both of those things are basically being unaffected. The other things I might want to look for, is it being shifted up or down? It is not. The midline is at 0, so I'm happy with that. So the only thing I really have to mess with is my period. The period for this function is 4 pi. And so what that means is normally a period is 2 pi. So this thing is getting stretched out by 2. So what I want to do is put a 1/2 in front of my t here. Now here's a little equation to find the period. The period is 4 pi if I want to find the b and I know the period, then I can do the b is 2 pi over the period, and that'll get you the b value. So you can always just do 2 pi divided by the period, and that'll get you the 1/2. And then we know that our b is 1/2, and we can plug that in. So thinking about it in terms of transformations or using that formula. Let's go ahead and try the next one. We are going to use a sine function here as well. Go ahead and choose the answer you think fits it. This one's a little trickier just because the period doesn't have pi in it. So if your period is 20, to find the b value, you're going to go 2 pi over 20, and you're just going to call that b pi over 10. And that's it. So your function is literally just sine of pi over 10 times t. And that is totally okay to have it like that. Example 6, this is your most important problem of today's notes. This is putting all transformations together for sinusoidal functions. The first thing I want to do is factor out the 3 so that I have a horizontal shift instead of a phase shift. So when I factor out the 3, I just did that wrong. Sorry about that. Apologies on this. That was correct. When I factor out the 3, I get a t minus pi over 12 here. That's all good. And all we're doing in this problem is just describing in words the transformation. So we're going to identify all of the different aspects of this. Now, instead of doing what I did in the box with the algebraic transformations, since this is sinusoidal, what I'm going to do is I'm going to use this b value. If b is 3, then I'm going to identify the period to be 2 pi over b. And then I'm going to use this h as my horizontal shift. Those are the only 2 transformations I see. So what I'm going to do is use the period and the horizontal shift to make this graph. Now, if you wanted to do the phase shift, so if you wanted to use this unfactored form, for those of you who are into it, let's make sure we discuss how this is used. The phase shift is pi over 4, right there. That's the phase shift, pi over 4 opposite sign. What that means is that you are going to shift 1/8 of the period because pi over 4 is 1/8 of the normal 2 pi, right? So the phase shift is a 1/8 fraction of the period. So what you are going to do is you are going to shift 1/8 of the period. Well, we already found the period to be 2 pi over 3. So we're going to do 1/8 of 2 pi over 3, and that should simplify to pi over 12, which is, of course, what we said the horizontal shift is. So for those of you who want to think in terms of phase shift, you're going to mark out the period, and then you'll just shift 1/8 of the way forward because pi over 4 is 1/8 of 2 pi. Now, if that's confusing to you, you don't have to use that. You can use horizontal shifts all the time, and that's totally fine with me. Here's the problem I was trying to get to. Example 7. Now we're going to graph it by putting everything together. And again, because I am not as interested in phase shifting, I'm just going to factor out the 3 here. So I have everything in the order I wanted in. If you just factor that out every time, then you don't have to worry about the phase shift. Let's go through and identify my different pieces. My amplitude is 3, and the negative will reflect me over. My period comes from the b value. Since b is 3, that tells me that the period is 2 pi over b, so 2 pi over 3. Okay? So we've got the amplitude, we've got the period. Now we're going to find our h value. H is the horizontal shift. Remember, inside changes are the opposite, so it's going to be a negative pi over 3. And then we'll look at our vertical shift, which is this -2 at the end. This is your midline, by the way. So our midline is at the -2. When I graph these, what I like to do is actually start with my midline first. So I'm going to take my midline at -2 and graph that in. I'm then going to take the amplitude, which is 3, and I'm going to go mark my max and min values. I'm going to go up 3, 1, 2, 3 to 1, and I'm going to go down 3, 1, 2, 3 to negative 5. So I'm marking my max and my min values on my graph. So I start with my midline and my amplitude. Then what I'm going to do is I'm going to take the period. Instead of trying to figure out where 2 pi over 3 is, what I'm going to do with every graph is I'm going to go 1, 2, 3, 4. That's the period. This is how I like to do it. There's other ways to do these, but I find this will be the easiest to do any type of trig graph. Mark 4 tick marks, and at the fourth one, put the period. Now, the second one is half of that. Half of 2 pi over 3 is 1 pi over 3. Well, the first tick mark then is half of that, so pi over 6. So this is like 1/6, 2/6, which is a third. The next one will be 3/6, which is a half, so it'll be pi over 2. And then 4/6 is 2 pi over 3. So that's how I can figure out what each tick mark amount is. Often, your H value, which is the last thing that I will use, by the way, will be one of the tick marks. If it's not one of the tick marks, that can be a little bit trickier. So let's go ahead and mark these backwards as well. Since my H is going to shift me left, I want to go ahead and get there. To start this graph, I'm going to take my H, which shifts me left pi over 3. And because it's a sine function, I'm going to start on the midline. So I'm going to go left pi over 3 and put a dot right on the midline. Then I'm going to go over to the next tick mark, which is that negative pi over 6 right there. And I would normally hit the maximum, except this was a negative sine function. So instead of going up, I'm going to go forward and I'm going to go down to the minimum. There's my next point. I'm going to go forward to the next tick mark and I'm back on the midline. Forward a tick mark and I'm at the top. Forward a tick mark, I'm on the midline. Forward a tick mark, I'm at the bottom. And I'm just following the pattern of sine here. The sine pattern normally goes from the middle, up, middle, down, middle, etc. Since I did negative sine, I just had it go down first. So this was the negative sine. So that's why I went from the middle, down, middle, up, etc. If I go ahead and connect these, I get this beautiful graph. And there is my sine function. You can go backwards as well. Cool. In example 8, since our very first point at 0 is at the minimum of the function, I am going to use a cosine graph for this. And in fact, I'm going to make it a negative cosine graph. Go ahead and identify all your pieces and then choose the formula that you think matches it. Since your function had an amplitude 3, you want a negative 3 in front. Since the period was 4 pi, you're going to end up with a 1/2 for your B value. And because the midline was up here at positive 3, you're going to add 3 on the end. Now, if you had chosen to write this in terms of sine instead, you absolutely can do that. If I was writing it in terms of sine, then I might have something like this, 3 sine 1/2 x minus pi. And let me just show you how this is the same. This would say, do a positive sine graph, but shift it to the right pi. So positive sine, if you shift it to the right pi, there's the positive sine portion. So by shifting this forward pi, now I start in the middle and then I go up, middle, down, middle, etc. So this is an equivalent answer that would be fine. Doesn't matter, but by using the negative cosine, then you don't have to worry about an H value. This last one's a little bit tricky, so I'll just work it out with you guys. So it looks like our midline is here at -2, so that's going to be my K value. And then the amplitude, it's still just going up 1, down 1, so that's fine. Now, in this one, it's not starting at the middle, top, or bottom. So sine or cosine, one is not necessarily better than the other. I'm going to go ahead and try doing a positive sine function. I see a positive sine function right here. So that means that my shift will be forward. My H shift will be forward 1. So it'll be a positive 1 for my H value. And the only other thing I have to figure out is the B. Since the period, it goes from 1 to 9, then it looks like the period is 8. So for your B, you're going to go 2 pi over the period, 2 pi over 8, and you should get a pi over 4. Once you've identified all those pieces, plug them in. So you have positive 1 sine, or just sine. You have a b of pi over 4, factor that out. And then you have an x minus 1 because your h is a positive 1. Don't forget the minus 2 at the end for the k value. Now, this is one option. There are other possible options that would work as well. The very last thing I want to cover with you guys today is this summary box with transformations for sinusoidal functions. Notice whether it's sine or cosine, I prefer to always factor out the b, so I use horizontal shift. In this format, once you have it formatted correctly, your amplitude is A, your h is the horizontal shift. To find the period, you do 2 pi over b. I'm using a little b, but you can use a big B, doesn't matter. And then the midline is always y equals k. The last little thing on here that's not super important, but may come up in problems is b over 2 pi, the flip of that. That's called the frequency. And what that is the number of cycles that are completed in unit time.